Okay, well, it's week 10, you guys. Week 10 Monday. We just have this week. I'm a little bit sad because that's the end of this class. I don't know. I hope you guys enjoyed the class. I hope you have. All right. I know instructor evaluations are out. Okay. So I want to encourage you guys to give me feedback. If you're also so inclined, you can leave a review at Bruin Walk as well. Let other people know about the class. Whatever you decide, that's fine. The instructor evaluations, I know people wonder, like, what good do they do? But they are very important for teachers, okay? In that we read the evaluations and our bosses read our evaluations. I am what's considered teaching faculty, a lecturer. I don't know if you guys know, but at UCLA there's two types of faculty. There's tenure track professors and lecturers, and I am on the lecturer side. So that means what that means is I don't do research, or if I did research, I'm not paid for research. I'm paid specifically for my teaching. So the teaching evaluations are weighted a lot more heavily in far as career advancements and things like that. And I'm still relatively new here at the university. This is my third year here, so they weigh more heavily, and so I appreciate your evaluations. Your honest feedback. Let me know what you think of the homework assignments and all of that, and I take everything into account and I try to make adjustments accordingly. So anyway, fill out your evaluations, please, and today I wanted to spend a little bit of time doing some housekeeping for the course. I know there's a lot of questions about grades, and you guys know how I feel about grades, in that I always want you guys to be focused on learning, but I know that's not how it goes. Okay, so this is what I have written in the syllabus. Okay, and I like to try to remain as faithful to the syllabus as possible, and I'm committed that if changes are made to the syllabus, the changes are made only in the student's favor. That's kind of my, I don't know, personal feelings, just because I remember what it was like to be a student. And where's my snipping tool? Okay, so let me copy this. All right, so this is what I have written down, and button. Okay, let me put this right here. Okay, it's like, oh gosh. All right, here we go. Okay, so I have this is what I have written. Okay, so this is original syllabus. All right, and so this is what we will do. Okay, so final grade scheme will be this. Okay. Okay, so it's still going to be 42% homework. Okay, and so basically you have 5 homework assignments. Okay, and they are 7% each. And then for homework 6, it's going to be a free 7%. All right, so that's going to just go in. So that's what we have, okay? So again, there's no, I think I made this very clear. There's no bonus for doing both homework assignments, okay? Do pick one of them for homework 5 and do it, okay? You're still responsible for, even if you do the Monopoly one, you're still responsible for learning Bootstrap, okay? You can't just say oh, I didn't do that homework, so I'm not gonna learn it. You still have to learn that stuff for the final, okay? The midterm has been, we're gonna do 15% midterm exam, okay? And then that remaining 5% will be free, okay? Again, the only. Okay. Don't. If that's all it takes to earn your love, we should have a talk about what love means. Well, actually, true love is not earned. It is always given unconditionally, whether it's reciprocated or not. Okay. Okay. It's still 30% final exam. All right. So prepare for that. That's as expected. Okay. All right. 5% class attendance. I'm going to have a separate slide regarding the class attendance, okay? Just because there's been issues with the class attendance, and I was mulling over my head what is an honest and fair solution. So we'll talk there, okay? And then the 3% Piazza participation. This this has like induced an unintentional amount of stress for certain students. It was just meant like, here's like an easy way to get some points and things like that. Okay, this is, I hesitate to show you what Piazza shows me because it's not anonymous, right? It shows all of the students' names and stuff. But basically, Piazza keeps track of everyone's interactions. They keep track of how many posts everyone has viewed. They keep track of how many things you've answered, how many questions you've asked, how many times you've clicked good answer, or you've come in and you've made a follow-up response and things like that. It keeps track of everything and it tallies everything up, okay? And basically, I was just gonna split it up. All right. Some students, okay, have logged into Piazza like 0 times and have viewed 0 posts, or I would say have viewed like less than 10 posts, okay? Now that I'm saying this, it's like I'm suddenly going to get like a bunch of people who logged in and get like 10 posts and stuff. Basically, I've already downloaded the report for up through 10th week Monday, okay? And basically, if you've gone through 10th week Monday today, and you've logged in 0 times, or you've read less than 10 posts total on all of Piazza, I'm sorry, you're going to get a 0 for the Piazza participation, okay? If you've logged in 0 times, like, you can't make it up now that it's 10th week, okay? Here, we'll have a slide here, okay? And, yeah, no, like, if you just log in and you click one of the questions and you read it, like, it counts that as a view, okay? Like, there's only like maybe a very few number of people who have reached this low bar, okay? So don't worry, most of you, okay? Most of you are not going to be in this thing, okay? So here, let's talk about the Piazza, okay? All right, just because everyone's like so worried about it's just 3%. Come on, okay. Okay, all right. So as of 10th week Monday, okay, if you have between 0 to 10 views total, all right, you're gonna get 0% for 0 out of 3. Okay. All right, and then the rest I'm going to. I'm just going to tier out as far as the rest, okay? It just keeps track of all contributions, whether you've asked questions or answered questions or whatever. And this I will run through okay, I'll get the report again. So this will be through 10th week Friday, okay? Basically, I'm just going to tier it out, okay? Top 33%, you'll get 3%. The next 33, you'll get 2. And then the bottom 33, I guess we'll do top 34, okay? And you'll get 1%, all right? Basically, if you've logged in and you've looked at it more than 10 views total, which I think is a very low bar because there's only like a few number of students who've done this, you'll at least get 1 point for Piazza, okay? And then everyone else is kind of tiered out. You know, I'm not a huge fan of curves, and I don't like the idea of you competing against your students, but I feel justified, or I feel okay that a total of 2% of your grade is going to be determined by a little bit of like how much you've participated in relation to your peers, okay? So that's the Piazza. Is that okay? Are there any questions? Yes?
So I can go on Piazza and see how many times you've actually posted, because like I posted like a few times here and there, but I don't know exactly.
Yeah, so there's a statistics tab in Piazza. I don't know what it looks like for you. I know what it looks like for me. And it keeps track of you. I know a lot of you guys have anonymity turned on, okay? But Piazza knows who you are, and they keep track of the statistics for me, and it just kind of summarizes everything in the thing, okay? I feel like this is fair. Okay, and then let's talk attendance. And we said 5% for attendance, all right, and 5% total. Okay. So as far as attendance, again, we're going to have 2% will be free, okay? And then the remaining 3% will be determined by your, I don't know, the online polling tool, okay? All right. And I've only taken attendance on a few days. So this will be determined by your online polling tool, and so like, I don't remember how many times, but let's say I took it, like, if I took it 10 times total, then, and you clicked a button, okay? So we're not like yes or no questions, it's just participation now, okay? And so let's say you signed in 7 times, okay? Then your attendance grade, so you'll get 70% of 3%, so that's going to be 2.1%, and your total attendance grade will be 4.1% out of 5%, okay? So that's how it's going to go, okay? There's an exception, okay, and there were 19 students who I did the online poll, and then I was like, these numbers don't match up, and so I went through the trouble of calling everybody's name, and 19 students were not honest, okay? Those 19 students, you're going to get a 0 for the attendance, the 0 out of 3, okay? Now, some of those 19 students later came to me and talked, and so I will show mercy and give you 1 out of the 3%, okay? So students who came and apologized, all right, I remember who you are, okay? Who came and apologized about what happened, all right? I will give you some forgiveness, okay? And you will get 1% out of 3, all right? All right? Now, if you want to come in and apologize now, I'm still willing to show you some forgiveness. So it is never too late to apologize, contrary to what popular song may tell you. It's actually a popular song from like 10 years ago now. So you can still come and we can talk, and you know, I will give you the dad talk about honesty and integrity being very important in life, and that we'll do that. All right. And if you're not sure if like you apologize, you just come talk and we'll have a talk. All right. And that's what we'll do. Okay. All right. Are there any questions on this? All right. So again, 2% free. So you're getting a lot of free points, right? You got homework, 5 free points from the midterm, 7 free points for one of the homeworks, and whatever it is. Okay. Yeah. And then at least, unless you're like at the bottom for the Piazza, at least a free point for Piazza and 2 points free for attendance, okay? Are there any questions on the grade breakdown that that's been set out here. Is this okay? Okay. All right. I can start talking about final exam topics now, or I can do something else, and then we can talk about final exam topics another day, like Wednesday. But I don't know, because your final exam's not for like till Friday of finals week, so I don't know if I want to like throw your burden. Do we want the final exam topics now? Yes. Okay, all right, fine. The other option, I'm going to talk about the statistics major, how all of your courses fit in the big picture of statistics and life. And you want that? Okay, we'll do that. We'll do that now. All right. Okay. All right. So, I might run out of time. Well, we can continue this. All right. I imagine most of you. Well, I don't know. Does anyone here? So, as far as statistics majors, and the field of statistics, I feel like it's starting to split into areas. And one side is going to be like data science. You've got tons of big data. You got to do machine learning and all of this stuff. Okay. And then the other side is statistics applied for traditional research. So if you're going into life sciences, health sciences, psychology, physics, chemistry, or whatever, you have traditional research that way. Okay. And so here I'll address both of those things. Okay. So all right. So we'll just say statistics will we've got traditional research, and then we've got, I don't know, data science, okay? Which is like this hot term, but it's statistics, guys, with a little bit of with a lot of computer programming, okay? All right, and so there's a picture that shows something like this. It's not a picture. It's called a Venn diagram. You guys seen this before, all right? And here we have this is titled Hacking Skills. This circle. And here we have math and statistics. And this circle would be the domain expertise. I guess they should go in here. All right, and at the center we have what we might call data science. Okay, your math and statistics, the traditional courses that go here would be the 100 series. Okay, you have 100A, 100B, 100C. Okay, these go in your kind of your math and statistics field here. And okay, hacking skills. This is all about like computer programming. Okay. So traditionally, I would throw in stats 20 in here. Okay. At the overlap between domain expertise and math and statistics, I would throw in traditional research. Okay. And under traditional research, I would throw in 101A and 101B. Okay. Under hacking skills and math and statistics, this part we might call we might call machine learning. Okay, and in this zone, I would put in the 102 series. And I'll talk about each of these. 102A, B, and C. Okay. And over here, hacking skills and domain expertise without math and statistics, this was known as the danger zone. Okay. Okay. And no classes are committed to the danger zone. Okay. And then data science, I would actually throw in 101C here. Okay. Yeah. Okay. All right. Let's and also the 140s. Okay, 140 and 141. All right. So let's delve into each of these things a little bit more. All right. Okay. So we have the 100 series, and this would be your kind of your traditional mathematical statistics, right? Traditional math and statistics. Okay, and so 100A is all about probability. And the key concepts covered in 100A is this concept of a distribution. Okay, a distribution of random variables. That's probably the biggest idea. Distributions of random variables. And how would you define what a random variable is? Okay. All right, well, I define a random variable as the outcome to a random event and the key part is the outcome is recorded as a number. Okay, so we record the outcome to a random event as a number, and that effectively makes it a random variable that we can now calculate distributions for. Okay, discrete or continuous, things like that. You calculate the properties of these things, you calculate how they interact with each other, and all of that, right? Okay, and then 100B, this is going to be your mathematical statistics. And I say this class focuses on the derivation and proofs necessary for many of the theorems that uphold statistical conclusions. Okay, so here we have derivations or proofs of many theorems that are critical for statistics, right? Because the whole idea about statistics is that we can make conclusions about the population based on just a sample. And so many of these things rely on using the central limit theorem. So in Stats 10, I really hope that you learned the central limit theorem and you make hypothesis tests and confidence intervals. And those all depend on the central limit theorem. And in 100B, you learn about deriving and proving the central limit theorem. You learn about things like maximum likelihood estimation. And so 100B is a prereq for many of the higher level stats courses, and I think that's necessary so you have an understanding of these underpinnings, okay? And then we have 100C, which is generalized linear models, okay? Maybe if I picked the name for the class for 100C, I would call this statistical models, just models in general. Yes, we are. Have you guys taken 100C yet? No, okay. So you guys are going to take it, right? Probably with Professor Christo or someone, right? And 100B and 100C are probably, well, if I were taking these classes, I would probably struggle the most with these ones, all right? Just because if I'm honest with myself, I feel a lot more comfortable with typing things into a computer than doing mathematical derivations, right? Like, I can do the math that's necessary for 100B and 100C, but just like, that's about the limit of my theoretical math, okay? Much beyond that, like I would struggle, okay? But you know, sometimes we get so focused on like all of these theorems and all of these relationships and stuff, we lose sight of what a statistical model is in the beginning, okay? All right, so let me give you a definition of a statistical model and just keep this in mind as you go into 100C and we have all of this stuff, okay? What we're trying to do is understand the relationships between one variable and another variable or several variables in the real world, right? We want to know, like, I want to be able to predict how tall someone is going to be, okay? What are the factors that go into determining how tall someone's going to be? There's lots of things, right? One is how tall was the mother? How tall was the father? What kind of food did they eat? You know, how many glasses of milk? How often did they go outside in the sun and receive vitamin D? There's lots of things, right? You know, and so what we're trying to do in a statistical model is we're trying to come up with a mathematical formula that says the relationship between this variable, these sets of variables, and this output variable is defined by this formula, okay? And so, you know, in linear regression, you probably learned something, and you get basically y is equal to, you know, beta 0 plus beta 1 x1 plus beta 2 x2, et cetera, okay? And then what is the last term that's always included in any statistical model? There's an error term, right? Because no matter how good your model is, it will not be 100% perfect. There's always going to be a difference between what you predict and what the actual outcome is. And so there's always something that we call the residual error, right? So the statistical model is basically a mathematical formula that tries to show or tries to model the relationship between different variables. Okay. So if you're an internet company, you want to know, is somebody going to make a purchase if I show them this advertisement or whatever, right? You want to know, like, who's going to spend money at my website, because that's the only thing that matters if you're an internet company, right? If they don't spend money at your website, like, you're going to go out of business. And so you want to know how do we get people to spend money, and then so you have all these things, right? Like, did they click on this page? Did they click on this page? Were they referred to here from a friend? Did they click the Twitter ad? Did they click whatever ad that showed up on this thing? A bajillion things to keep track of, and you are just trying to understand what matters over here and the result that you're interested in, okay? In linear regression, this is linear regression, right? You just have a linear relationship between each x predictor and y. Okay, if you just separated one out, it's just a linear relationship there. And generalized linear models is just, you know what? Let's throw in some kind of transforming function, okay? So this here is linear. And then if you decide, you know what? Instead of having this, we're going to throw everything into, you know, a log of b0 plus b1 x1, et cetera, or you want to throw it into e1 divided by e to the B0 plus B1 X1, et cetera, et cetera, et cetera. You know, you have different options. You've got like logistic models and things like that. It's just, you've got a linear relationship, you're throwing it into some other formula here, okay? But you're always, at essence, you want to get something where you have predictors and outputs and make this, okay. 101, the 101 series, let's talk about that, okay? So 101A is all about regression, okay, linear regression. And we've already talked about, this is kind of like the most basic, but also most basic, but very versatile statistical model. And it's worth having its own class dedicated to this one statistical model. So that's linear regression, right? Okay, and then 101B, are you guys taking that right now? Or is that next quarter? Next quarter, okay. So this one is, what's it called? Design of experiments? ANOVA? I don't know what it's called. I don't know the name of the title, but I know what's covered in it, okay? Design of experiments / ANOVA, right? This comes from a time where acquiring data is expensive. This acquisition of data is expensive. And this is really, this was the driving force for statistics as a field 100 years ago. Like, statistics would not exist today if this fact was not true. Okay? If data was easy to acquire, statistics would not really exist today. That's kind of my hypothesis, okay? So acquisition of data is expensive, right? You want to do a medical research study, you want to test out if a new treatment for cancer is effective. It's very expensive, right? Because first of all, cancer treatments are expensive, but to see it, I mean, is it effective, you need to have a patient who's willing to volunteer, okay? You might have to pay them money, you might not, but then you need medical staff to administer whatever treatment it is. You need to train the medical staff on how to use the treatment properly and all of this stuff, right? And then you also need to compare this to people who are receiving traditional cancer treatments and things like that, okay? So every single person that you are tracking is probably going to cost thousands of dollars just to acquire that data, right? And you might be well funded from some major pharmaceutical company, but even just to have like 40 patients in your study is going to cost thousands and thousands of dollars. And then if you wanted more than 40 patients, it's going to cost even more, right? So, so let's say you have a total of, you can only afford 40 observations, okay? Right? We saw the Mythbusters experiment, and they were like saying we had the biggest sample size ever of 50, and they spent all day just acquiring silly data about like who's gonna yawn or not, right? So if you can imagine that anything that's even slightly more important, which is everything else in the world, it's gonna cost a lot more, right? And just to acquire those 50 data points, they had to spend an entire day, so that's an entire day of wages times every single person and all of that equipment, renting out the trailer and all of this stuff, right? So you might only be able to afford 40 observations. And so how can you maximize the amount of information to extract from these 40 observations, right? So we need to maximize information we want to extract. Okay, so this involves things like reducing redundant observations when it's not necessary, right? We want to, or being realistic about the kinds of effect sizes you can detect. Like if we can only afford 40, we're only going to be able to detect if the difference between one treatment and the other is at least this many points, and you have to decide how big of a difference is important enough, right? So all of these things, like determining what is important and stuff like that, what is important, reducing redundancies, these all kind of factor in there, okay? Okay. And I think in 101B, the main driving project is this thing called the island, okay? I don't, you guys who's in 101B and did the island? Okay, all right, so I'm not making this up. Okay. And it's a pain, right? It's like you have to like click every single person, and it's like you got to click and then you got to wait for all of this, right? It's just the tiniest bit of taste of getting the idea of acquisition of data is expensive. Like they put you through pain by making you wait 4 minutes to get back the result of a thing, right? And so the point is you're not going to say like, oh, for my project, I'm going to survey 300 patients on the island. Like, that's a waste of time, okay? You want to be able to make the same kind of conclusion that's important based on a lot fewer things, right? So if you started off your study and you said, I'm going to get 300 observations, maybe it's too late. You already went out and you had to sit and click through 300 observations. You've missed the point, okay? I think I heard somebody talking about like, I'm going to write a computer script to go out and calculate, like gather all of these observations. That's not the point, okay? The point is, because you can't do a computer script for a medical research study. You can't just say like, oh, this part's painful, so I'm going to just say like, no. Painful acquisition of data is part of statistical research, and so you want to maximize the amount of information you can get. That's what 101B is all about, okay? And then 101C is data mining, and I would say this is actually this counts as a data science course, all right? And I haven't talked about the 102 series. There's one circle where there's no statistics courses, okay? So let me, and that is the domain expertise. We don't have any courses dedicated for domain expertise. And the reason for that is because it's not going to be in statistics, right? Wherever you're going to do data analysis, it requires you to go outside of the field of statistics. You don't do statistics for statistics' sake for data analysis, right? Yes, we have statistics research for statistics' sake. That does exist. But it's almost always driven by the need that some data exists and it needs to be analyzed. And you need to have understanding of that field where the data has been obtained, okay? You cannot just say I'm a statistics expert and get information from a country or culture or scientific field of which you have no understanding or no knowledge and expect to just be able to throw some algorithms at it and get answers, okay? You need to understand like what these values even mean in the first place. And you need to have some idea of the relationships that exist, okay? So from our experience, we are probably, we have knowledge about like things at a public university and stuff, right? Or just, things that are relevant to you. But if somebody says, hey, I've got some information, right, can you analyze this medical data? You can't just say, sure, let me take a look and throw it in R. You need to understand like how this medical data is obtained. What are the factors that doctors and scientists believe would make a difference in the first place? And you should have some general sense first, and then once you have an understanding of this specific domain, then you can start applying models. We cannot just throw things at a computer and expect it to figure things out, right? Even like there's like all these I don't know, I've watched a bunch of nerdy things on YouTube, and one of them is like they try to teach a computer like how to play a video game, and they just say like, they have like these organic learning algorithms, and basically they just say this. Even that requires somebody to say, what we want to do is we want to maximize a score or something like that. We want to achieve something, and it requires at least some base knowledge of how the video game works, or whatever it is. We need somebody to be able to program a goal that the computer wants to achieve. Okay, so domain expertise. This is important. Okay, and so if you have a sense of like, you want to enter data science in a certain field, you need to obtain some knowledge there. Okay, it's very important to have an understanding of where the data is coming from. Okay. And I know for your homework, you're looking at certain data sets doing bootstrap and things like that. And you need to take a look at the code book to understand what even these variables mean. And it's unfortunate that the textbook doesn't actually provide a whole lot more information than the code book itself, which is something a little bit sad, because the analysis of education achievement for immigrants from Latin American countries and Mexico, we had no idea what that actual number means. Okay, and I feel like we're losing a lot in terms of what we're able to conclude and communicate at the end of the study, because saying there's a 5-point difference is not meaningful in any sense of the word, because we have no idea what 5 points means. And so, so the domain expertise is a vital part in terms of being able to communicate your findings. Okay, I guess we're out of time. I'll talk about the 102 series, which is very near and dear to my heart, I guess on Wednesday, and then we'll talk about topics on the final exam and things like that. Okay, if you're inclined, please leave course evaluation, and we'll see you guys on Wednesday.